So we'll now do the McNemer test. So this McNemer test, it is very much similar to the paired t-test, which we will learn tomorrow, because here it's basically practiced more in pre-post sort of study. We'll see this. So again, like all other sessions, we are going to learn the basic concepts, the research questions, assumptions and hypothesis, commands and interpretation, and again, once again, the revision of those commands. So let's start with the characteristics of the McNemer test. So this McNemer test is a non-parametric test. Like all other chi-square and all, these are the non-parametric, because you see that we don't check for normality or outlier in case of any of these tests, because these are non-parametric. So the data is normally distributed or not, there is outlier or not, we are not bothered about that. So it is again a non-parametric test, and parametric is, you know, there is a classification of a parametric and non-parametric. So when the sample size, when the data is skewed, we apply non-parametric, and when the data is normal, we apply the parametric. We learn more about this parametric and non-parametric in tomorrow's session. Then we are going to learn independent sample, ANOVA, paired t-tests, etc., and they are the non-parametric counterpart. So this McNemer test is a non-parametric test for a paired nominal data. And again, this McNemer test is applicable only for two categories. That means there should be two variables and it should have two categories. If a variable has more than two categories, then we cannot apply this test. So in this case, we see the change in the proportion of the paired data. And this is also called the McNemer chi-square test, because ultimately it is using the chi-square statistics to calculate the test. So that's why we call it as a chi-square McNemer test also, or the McNemer chi-square test also. So it is applicable again in certain study design, like you have seen in the chi-squares, this test of two proportion, difference of two proportion, that you have to take two independent sample and then see the proportion of something. Similarly, in this case, in this study design, it is applicable in a pre-post study where you measure the change over the time with intervention or without intervention. So it can be with intervention or it can be without intervention. Like you can measure the two, maybe the blood pressure in one summer and winter, and you are not doing any intervention, and then you can see whether there is any change in the value of blood pressure or not. Similarly, if you have done some intervention and then again, like maybe exercise therapy, you can carry out this therapy or yoga therapy to some group of individual, and you can measure the depression score before and after. And maybe it should be a categorical, so not score, rather people who are depressed versus not depressed before the yoga therapy and then after the yoga therapy. So it depends whether you are having an intervention, or it can be done at two different time points without intervention also. Or the third situation, it can be done if there are differences between conditions, like we did for the crossover design. So you have one variable, you expose them with one intervention, and then again after certain time you again expose them with the second intervention. So that can also be done, like we did for the chi-square test of two proportion. There also we did the similar thing. So in this case, you can measure a categorical variable X on the same individual, like for systolic blood pressure in summer and winter at two different time points, and you are categorizing it as a high and normal, because it cannot have more than two categories. You should remember this. McNemer test can be applied only for 2x2 contingency table. For 3x2, 4x2, and 4x4, you cannot apply McNemer test. Then again, if you are going to do some intervention again before and after, like you can measure any outcome variable, maybe the systolic blood pressure before workout and after workout. Again, you can measure this systolic blood pressure in right arm and left arm, or you can measure on the same individual with two machines, one with the automatic BP machine and second with the manual BP machine. So in all these cases, what have you observed? That the observations are not independent. The two columns will have the same number of individuals. So we call it as a paired data. So in McNemer test, it is a paired data. The paired data can be right arm and left arm of one individual, that is also paired, or one individual measured at two different time points, or under two interventions, or by two different instruments. Or you can measure a categorical variable, maybe like depression status, same for the two different time point without any intervention, with one drug and with more than one drug, or before counseling and after counseling. So this is the study design which is applicable for McNemer test. Now, what is a research question? So the research question is whether you want to know any change in the proportion scores of a paired observation. So the first research question could be whether there is any difference in the proportion of BMI status, where you have categorized the BMI as normal and high before and after a 6 weeks exercise program. Or you can compare the proportion of pain status, moderate versus severe, measured on VAS scale before and after surgery. Or you can do like any difference in proportion of the passing students against the pre-university and university examination of the MBBS students. So you will see that the set of individual are same. In the first case also, you are measuring it before and after 6 weeks exercise program. Here also you are measuring before and after surgery. Here also they are the same individuals which you are doing before pre-university and like university examination. So in all these cases, what have you observed? That there is a dichotomous categorical variable and you want to compare it before and after. So in this case, the appropriate statistical test is the McNemer test, and such type of research design is known as the pre-post study. And we apply the McNemer test of paired proportion in this case. So there are a few underlying assumptions. The first assumption is that one dependent variable which should be measured on a dichotomous scale. I have emphasized this, that if it has more than two category, you cannot apply McNemer test. The second is that independent variable, it should be of two categorical related or matched pair. And the cases, generally, they are the random sample from the population of interest, but many times this is not possible. So the null hypothesis in case of a McNemer test is that the population proportion difference between the paired value is equal to 0. And the alternate hypothesis states that the population proportion difference between the paired value, that is the P2 minus P1, that is not equal to 0. So now coming to the question. So the question which I have to demonstrate is I want to see, there are two questions. So I want to see whether there is significant difference in the oxygen requirement, status of COVID cases at admission and just before the discharge or death, maybe, because there are two status. So just before the outcome. So I have to see just before the outcome. And then again, the second case, I have to see whether any significant difference in the admission status, that is the ICU versus ward of the COVID cases at admission and just before the outcome. So for that, this is my data set. I'll go to this frequency. In this case, you can see there is an option in contingency table. There is a paired sample. This is the McNemer test. So in McNemer test, you have to move your variable in rows and column. Now the question is, I have to see whether there is a significant difference in the oxygen requirement. So oxygen requirement would be my dependent variable. So I am taking this oxygen 1 here in this case, because it is not independent, dependent, rather it is the two observation. I'm sorry, I should not have made this statement because there is nothing independent, dependent in this case. They are the paired values. So I have taken oxygen 1 at the time of maybe admission and at the time of at the just before outcome. And then this chi-square, because I said that this is the chi-square test is there in this case. And then there are nothing more. And in this case, you don't need to click on these percentages then, because then it will complicate the analysis. Now focus on this table very carefully, because those of you who have attended the SPSS, maybe it's a repetition for you people, but those of you who are attending it for the first time, this McNemer test is also known as the test of marginal proportion. So what do we understand by marginal proportion here? So now this is a 2 by 2 table. Here you will see this is oxygen 1 and this is oxygen 2. Means this is the oxygen requirement at the time of admission and 2 is the oxygen requirement at the time of discharge. So this is 1, 2, there are 2 rows and there are 2 columns. So if I focus on this row represents the at the time of admission, means the first observation. So how many of people out of 180 they have required oxygen? Please type in the chat box. If you focus on this, I am saying that this row represents the first observation. That means just at the time of admission. And this column represents at the time of discharge. So now you have to write the number of people who required the oxygen at the time of admission and the number of people who required the oxygen at the time of discharge. All of you please write in the chat box. Can you show me the chat box? 48 and 19. Yes. Anybody else? Can you show me a little bit who else have answered? Okay. Okay, so you are right. 48 were requiring the oxygen at the time of admission and 19 at the time of discharge out of 180. So you have to calculate the proportion. So can you tell, and if you see this p value, can you say that this is a very significant? Because p is less than 0.001. So this is highly significant. That means almost it has reduced by more than 50%. 48 and 19. You can calculate the percentages. Like you can calculate 48 by 180. This was the previous requirement when the person admitted. And at the time of discharge, it was 19 by 180. This will be the difference in like the proportion, the less proportion of people who require oxygen at the time of discharge. And it was highly significant. That's why we call it as a test of marginal proportion. Because see, we are only calculating margin. This is one margin and this is one margin. So you need to focus only on this 19 and 48. That's why I'm not clicking on any of these row and column percentages because you have to, yes. So 26% and 10.5, you can write that 26% of the people, they require the oxygen at the time of admission, which decreased to 10.5% at the time of discharge, which was significant. And you can give the value of chi-square along with its p-value. Is it clear to all of you how to interpret it? Then
yes,
again, okay, then I'll go to the second question where I just want to check about the status of people who have there in the ward and ICU at the time of admission versus, and I'm taking the same individual. Remember, if you remember the study design, in hospital, you have to follow the same individual. It cannot be possible that at one point of time you take the discharge and all the data and then calculate it. You have, because it's a paired data. So same individual status at the time of admission and at the time of discharge. So for that, what I will do, I'll move this back. And then maybe I will write this admitted because this is the status of admitted patients at the time of admission and this is at the time of discharge, ICU versus. So you can see here again that this is also significant, although not highly significant, but this is significant. And again, this is a test of marginal proportion. So if you want to focus on ICU, then you can focus on this, that initially there were 24 people and later this number has reduced to 19. And if you want to focus on ward, then you can take this one, this and this, like we discussed in the previous example. So again, this proportion, you have to write the proportion 24 out of 180 and 13 out of 180. This is again, it has decreased maybe 50% because 24 and approximately 12. So it has decreased and this is also significant. So this is the McNemer's test, the pair test of two proportion. And similarly, you have to write the interpretation. and the research question. So is it clear to you? It is like a paired t-test, but in the paired t-test, we take the mean, continuous variable. Here we are taking the proportion, and the proportion should be again binomial. It should be a 2 by 2 category. We cannot take more than 2 by 2. So if it is clear, then we will again, so again, command, there's nothing in this command. I'll again revise the command. You have to go to this frequency, and you can see that there is an option of paired sample. And once you click this, this window will appear, and only you need to click this chi-square. That's it. And then calculate the percentages based on this marginal percentage or marginal proportion, depending on the variable of interest.